Alright, back to the grind. See if I can do this pretty quickly. Power grid maintenance medium. You're given a C integer C representing C power stations, each which have a unique identifier ID from 1 to C, 1 base index. Okay. These stations are interconnected by n bidirectional cables represented by a 2D array connections where each element connections at I is U sub I, V sub I indicates connection between station U and V. Bidirectional, so U connects to V, V connects to U. Stations that are directly or indirectly connected via stations that are directly or indirectly connected form a power grid. Okay. So it's kind of a graph. Initially all stations are, or connected graph. Actually all stations are online, operational. You're given a 2D array queries where each query is one of two types. 1, X is a maintenance query. A maintenance check is requested for station X. If the station X is online, it resolves the check by itself. If station X is offline, the check is resolved by the operational station with the smallest ID and the same power grid as X. If no operational station exists, it's online, it returns itself. If it's not, then it returns the smallest connected thing. Okay. If there's nothing, then it returns -1. Station query 2 X means that goes offline. Oh, okay. Return an array of integers representing the results of each query type. So this thing doesn't have a return. Or does it? Okay, results in the query of type 1x. So the return array doesn't actually input anything for a query of type 2. So they're all connected. 1, 3. Interesting. 1, 3. So query on 3 because 3 is operational. Does it assume that we start everything operational? All operations. Okay, yeah. So 3 is operational, returns 3. Query type 2, 1. So 1 turns off. 1, 1. So 1 needs to return the smallest operational thing. So it's going to be 2. So that's that. 2, 2, 2 is no longer operational. 1, 2. So now it's connected to 3. Okay. So let's say I have a grid ID and let's say I have a grid ID counter. This is going to be a kind of a static counter that assigns connected grids to an ID. I think I need to have a default dictionary of, actually, do I need a default dictionary or can I use an array? I think I can use an array. Grid, well, what's this going to be? This is going to be, what are these things called? Station map. And it's going to be, let's say, -1 times the number of connections times C plus 1, because I'm going to use the station index, or the station ID as the index into this thing, and this thing's going to map key of, or index of station ID and the value is going to be value at the index would be the grid ID. This is a grid counter to assign grid to unique IDs starting at 0. And so grid IDs, grids are basically connected islands or connected graphs. Okay. I think I need one last thing, which is the low. Each let me think. Need some sort. I need a map. I need to map the grid to the low of the grid, or the lowest operational one. I could just use. I could use a set. So it has to do some sort of map. Low grid, and this is going to be. I'll say this is going to be 0 times c plus 1. For now, map. I need to map the grid ID to the set of things in that grid. Set of things that are operational to the grid. Yeah. Grid set is going to be a set for every. I think actually this thing needs to be. This would be an array of sets. Of operational stations for every grid. So the index is the grid ID, and the value is going to be the set. And I probably need maybe like grid, like low grid or something, to map like grid ID to lowest operational station. So I'll have to look for the minimum of the set each time. Okay, so the first thing is going to be to form the graph. So I think this should be visited is equal to an empty set, and how do I form graphs again? Yeah, so this is probably going to be default dictionary graph. Default dictionary of the list. And this is going to map station ID to list of connected stations. Or maybe this should be a set. List of connected stations. So for every x, y in connections, graph of x appends y, graph of y appends x. And then I guess this could possibly be, I could possibly make this an array of lists as well. Yeah, whatever. think I do need visited. Yeah, probably. Okay, so for every station in the graph, station ID in graph.keys, I think graph is probably fine. I think this is correct syntax. I think this prints out 1, 2, 3, 4, 5. Okay, yeah. Sometimes I forget if I can use that syntax or if I have to use graph.keys or something. Alright, so for every station ID, if station ID is invisited, then skip it. Otherwise, visit adds the station ID. So forming the graph. So this should graph, the station should be grabbing the current grid ID counter. So current grid should be grid ID counter. Grab that, and then grid ID counter should increment. Maybe I should call that grid ID. So if this is like grid ID 0, then I need to probably have a stack, process stack, and push this ID into it. And then while there's a process stack, and then pop the station from the top of the stack, assign that to the current ID, station map. Yeah, so I can do station map of this current station assigned to this grid ID, and also the grid set. The grid set for this grid ID is going to add this station. I also should say, I guess visited can be done afterwards, maybe. Then I need to go through all the neighbors of this thing. For every neighbor in the graph this of current station, if the neighbor has been visited, then skip it. Spelled. Otherwise, I'm going to say visited includes this neighbor, and then I'm going to process this neighbor. Process dot append the neighbor. And then I think that's it. And then that goes in the stack. Process pops the neighbor, assigns it to the current grid ID, adds the station to that grid set. Loops, 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 loops. Okay, I think that's correct. Okay. Then the answer should be an empty array. I think I can do offline. Is this another set, maybe? And then for every query, so the query is the type and query type and query station in the queries array. Every queue type and queue station, if the queue type is 2, then offline adds this station. It continues. Otherwise, it's going to be the tricky one. If the queue type is 1, then if the station is not offline, then just append the station. Otherwise, append the lowest that's connected to. So the grid ID should be the station map for the current station, the queue station. And then I need to find the lowest. Of that grid set that's operational. Okay, so that means I need to actually remove it from the set here. So if it's offline, then I need to remove it from the set. So the grid ID is going to be station map queue station. I guess I do this in both cases. Not necessarily if it's not offline. Okay, whatever. So grid ID equals station map of the queue station, and then the grid set for this grid ID should remove the current station. And I think here, so all the offline stuff has been removed from the map here. So it should be answer.append the minimum of whatever the grid set is for this grid ID. I think that's correct. And then return the answer array. Out of range, really. Grid set, grid ID is out of range. Oh. Line number 24. Really? Station map. Process the grid ID. Grid ID. Oh, I see. Okay. I made the grid ID, I made the grid set be an empty array. I need to actually, each time I do a loop here, at this point I need to create an empty set for the current grid. Yeah, I need to create an empty set for the current grid. So grid set is going to be empty here, and that's what I add to. Grid, I called this grid set already. Call this current. This should actually be grid sets. Or I can call this current set. Plural versus singular. Alright, whatever. I think there should be current set to add the current station. And then after I do all this, I do something like grid set. Grid sets should be adding or append the current set. Should be plural. Grid sets station map. Grid sets. Current set, grid sets. Grid sets for that grid ID, remove. Grid sets the minimum. Okay. Invalid key, grid ID. Why would that be invalid here? Array of operational stations. First grid ID should be 0. At that point, the grid set should be an empty array. Does this thing, it's 0, and then grid sets append the current set. And everything here should be mapping to that 0. Grid ID, station map queue, query station. Grid sets for this grid ID remove the current station. Alright, let's go ahead and look through this. For every G index in grid ID counter, print the G index and the grid sets for this index. What is going on here? Not iterable. Grid, oh, let's see, range. So that's correct. 0 ID 1 2 3 4 5. 0 ID 1 2 3 4 5. Key error 5. Somehow the grid ID. Okay, let's see what the station map pair does. Print the station map. Should be like 0 to 0, 1 to. Yeah, okay. 0 to 0, 1 to 0, 2 to 0. That's all fine. So offline add queue station grid ID equals station map. That should be 0. Remove the current station. Did I flip this? X 2. Alright, fine. Print. This is remove queue station grid ID. Oh, I'm missing something pretty basic. Huh. Maybe key error 5 doesn't mean that the key here is 5. Not sure what key error 5 means. Remove 1, 0, remove 2, 0. That seems actually fine. The station ID is 1, the station ID is 2. Grid ID is 0 each time. Grid sets. We drop that thing from the current. Oh my god, I'm using current station. This should be queue station. Oh my god. Move 1, -1. Oh boy. Is this the second example? 1 is connected to 1. No. Okay, there's 3. Okay, yeah, there's 3 things, but none of them's connected, I see. So 3 things, none of them's connected. And somehow that made it so that none of them were actually part of any stations, any grids. I assume that they are all part of some mapping. I see. Okay. I think this should be every station ID in like the range of 1 to C plus 1. Yeah. I think that's better. Okay. Min arg is an empty sequence. Interesting. Yeah. Whoops, there's the chance that none of it's operational. Oops. If there is something grids sets of grid ID, then do this. Yeah, I should have caught this earlier. Else answer appends -1. Okay. I think there is one optimization I could do, which is storing the minimum and only updating the minimum if it's removed. If that minimum is removed from the grid set. But let me see how this fares, and then I'll maybe do the optimization. Oh boy. 2 past 1. Line 42. Grid sets. Line 42. Really. Oh, what's going on here? C is 1. There's no connections. There's no connections at all. So there's an empty graph. So it's probably going to crash when it tries to... Is it going to crash? What's going on here? There's one city, so its grid ID 0. So let's see, what does this do here? So this thing should return 1. Turns 1 off. Oh, it's returning 1 off repeatedly. I thought it could only return 1 off. Thought it wouldn't have multiple queries to turn off something. Okay. So offline add. Yeah, this should just be discard. Because it can have it multiple times, removing that item from the set. Remove requires the element to be in the set to be removed, and discard is optional. Oh, is it too slow? Really? Runtime error? Okay, it is too slow. Okay, so I think that means I need to store, well, that could mean that I just need to optimize it. So I think grid mins is going to be, let's say, -1 times the number of grids, so grid ID counter +1. And so if the counter is at 0, yeah, I think it's counter +1. And I think I go for, well, actually maybe I just go something like grid mins is equal to an empty array for every grid set in, for every G set in the grid sets, grid mins appends the minimum of that set. Okay. So it does it really once. Okay. Possible. Yeah, every set should have at least one station, so it should have a minimum at the moment before things go offline. And then when things go offline, I need to check if this offline grid is the minimum. If Q station is equal to the minimum, is equal to grid mins of this grid ID, then update, find a new operational min. So this will be if there are still things in the grid sets of this grid ID. I guess I can just do something like grid mins of this grid ID is equal to -1 if there's nothing there. Let's say it equals the minimum of grid sets for this grid ID, else, so if grid sets of this grid ID is this, else is -1. Okay. Offline. And then if so if it's not offline, append the station. If it is online, then if it is offline, then I don't need to do this. I just need to do answer append the grid mins of this grid ID. Okay, I think that should be still fine. See if it's faster. Hopefully it's fast enough. Ooh, that seemed kind of slow. 209 milliseconds. Eeks. Might be too slow still. Huh. Guess I could have. So 669. No, this is a different test case. Okay. Interesting. Guess I could have kept track of the minimum here actually. Grid min is going to be the station ID. Yeah, actually the station ID should be the smallest, really. I guess in that case then I should just wait, how did I do this before? Grid mins. Yeah. Okay, so the station ID is always going to be this first one. Yeah, the station ID that first encounters and makes the stack should be the minimum. So I think I should just add like grid mins appends the station ID and not have another flip to do that. Oh, I'm doing prints here. That's probably slowing it down considerably. Don't need this. This is the whole thing I got rid of. 211 milliseconds still. Okay, let's see how fast this goes. Doesn't seem very fast. Yeah, it's probably gonna time out again. Really? Are the connections known to be like one connected to the next? What's going on here? Is there something I'm missing? Indicates connection between U and V station directly connected to power grid. I'm really surprised that this thing is going so slow. Just doing a test case here to see how long it takes to just do the graphing. Because it seems to actually take a very long time to just maybe 79 milliseconds see the graph out of like, just remove that test case. So just test case 1 through 4 was like 200 milliseconds. 211 I think it was. So it takes like 50 milliseconds, so 25% of the time just to make the graph. It's a lot of connections. C is 5 or 10,000, 100,000 connections. I mean, I think I need, yeah, I mean, I could use a array rather than a default dictionary here. Oh gosh, is this why? Is an array of lists that big? Okay. Graph is equal to list for every C in range of C plus 1. I think that's correct. Okay, let's see how this goes. Rather than using a dictionary, I'm just using indexing into an array of lists. I think it's still pretty going. Yeah, it's still going. Well, let me see actually. Yeah, still going pretty darn slow. 51 seconds, 51 milliseconds versus 55, it went slower. Okay, let me just make sure this actually does work though. 211 milliseconds was the last one, I think. 165. So slightly faster, but not really all that much faster. Really surprising. Like this thing. This thing is really surprising. 1, 2, 3, 4, 5. I mean, what can I do? I guess maybe this min thing is not. Let me think. So if you have a really big set of connected things in the grid, I guess what you could do is you could sort it once. You could sort it once, have an index to the list of stations and increment increment that index, find the next available, because you are returning the minimum. It's the smallest ID. Yeah, I guess. Okay. Okay. So I guess you need a grid list. Really, you want this to be, yeah, we grid lists and maybe reverse sort and then pop from the list. Grid list. Okay, so grids. So this is list, and array of operational stations for every grid value is going to be a reverse sorted list. Okay. So wherever I did grid sets before, I need to change. So this thing should be the current list. And then grid sets, current list dot append current station. Let's see. Yeah, I need to reverse sort this anyways. Okay. I was thinking of using a double-ended queue, a deck for it. But it's not necessarily going to be in reverse order, or not necessarily going to be increasing order when you first input it into the thing. Current list. So grid list. So first here I need to do current list dot sort reverse equals true. Grid sets append current list. Grid list. Okay. So then, okay, so when it goes offline, then it just takes itself off of the, so it doesn't update the sets here. Shouldn't update the sets because it's just going to be on the list. And then queue station. I think this is updating it still. Guess maybe I should comment it rather than delete here. So it doesn't update the grid mins in this spot. Although the grid mins at this point, is not needed because I just looked at the back of the list. Okay, I think I need to just remove grid mins. So then when it queries, if it's there, then it returns a pencil station. If it doesn't, then it's going to only I could put a -1 at the front of the list. I don't think I can. Okay, so this should be min station should be equal to -1. Actually, I'm going to remove all the non-operational stuff from the grid list. So while grid list and grid list, the last station in it is in offline. Grid list at this grid ID. grid list at this grid ID pop. So the min stations be -1, or min station be grid list at this grid ID. Last one, if grid list exists for this grid ID, grid list. Else it should be -1, and then append the min station. Oh, still slow. Oh, not defined. Line 61. Log grid list and yeah, okay. Looks like it's still too slow. I think it's out of range. Really. Oh, whoops. My grid list at grid ID. Yeah. Too slow. 154. So literally no improvement. Literally no improvement. Oh. Alright, I'm just gonna run it. Well, actually, where was that time limit exceeded test case? I'm like 3 away from all the test cases. What is slowing this down so much? I guess that's 257. I guess that's not terrible. Okay. Okay. Huh. Thought this was pretty darn optimized. Well, I guess I also thought the first part was optimized before I did this, but what else could I do here? So you have to make a graph. I think that's really necessary. I mean, I guess I could try going back to default dictionaries and seeing if that made any sort of difference. I can only guess that that made it worse, though. And that was worse than making a list. Graph equals default dictionary of lists. Guess maybe I can make it a default dictionary of sets. Yeah, no way that's any faster. Three, 339. Holy cow, this is slow. This is probably the same speed. Oh, okay. 421. I guess that did make it slower. Okay, going back to the array of lists rather than the dictionary of lists. Okay, so delete that. Visit. You need to have that set for sure. To view, I guess you could maybe make that into an array as well. Yeah, you can make this into an array. So false times c plus 1. And then if station, so if visited at station ID. like your memory is just gonna get worse and worse here. And then instead of doing visited.add, it just visited at station ID equals true. And then here visited at the neighbor ID is equal to true. In theory, the set and the array should be the same size memory-wise. Same thing here, offline, you can make this to be false. Actually, you could actually use the visited at this point. Offline is visited. Because after you do this, everything, all the stations should be true. So you're just using the same array of booleans. To save memory. Basically an array of true size, a station length size array of true. Okay. Actually, so offline it should be initially false. So I guess this if it's all initially true here, then this should be online. Fuck. Visited is true, they're all online. So now online needs to be online for this queue station should be false. And then so this is going to be online. So while not online with this gridless, this is the station ID. Okay. I think that's correct. Doobie doobie, doobie doobie. Wow, so slow. Did I make it go infinite? Oh boy. Well, it's just doing the test cases, so it's just something I did wrong here. Visited, false. Visited becomes true. Visited becomes true here. Oh, Jesus. If neighbor isn't visited, if visited of neighbor, that's true, then continue. Online Q2 online becomes false. And then while the back is not off, if it's the back station's not online, then remove it. Okay. Hopefully this doesn't go infinite again. Seems like it might still be. Oh, did I not change? 43. Oh my god. While online What is Q station? Okay, I guess that's fine. 171 is about what it was before all this change. 318. I think this is the best result I've had. Okay, so I removed basically all the maps and sets, or all the hash maps and sets, so that it doesn't use some hashing function to figure out stuff. I think this is fine. Reverse cut this, reverse sort, append. Use a lot less memory than other people. Interesting. I guess it's probably because they use maps or fixed arrays rather than sets and hashes. Station ID. Create a list. Graph. Station ID. Grid ID counter. Increment process. Pop. Station map for this grid ID is station map for this current station is the grid ID. I think that's pretty darn necessary. I guess I could just map it to the set, maybe. No, that's not good. Yeah, definitely don't. I actually don't even have the set anymore. I don't actually. Can I map it to? I wonder if I could map it to the list. Could map it to the list. Reference to the list. What would that do for me? So I wouldn't need the station map. I could just map the current station to the reference to a list of operational stuff. And then I wouldn't need to keep track of grid lists at all. So station map maps from station to the list. So it would be station map. Is that worth it? I think it might still be worth it because it's probably the same, slightly faster. Station to list is going to be, I guess it's the same thing, right? It's -1 times c plus 1. And I would need to do something like station to list. Station to list for the current station equals the current list. It's called station to list. Station to list. And then I reverse sort it. This is in place, so the current list reference should be modified. And then this is still the same. I don't need the grid ID at that point. I guess at that point I would just reference the current. I would just reference station to list at that point. So while station to list for this queue station exists and the last thing is not online. Not online station to list for this queue station. Then station to list for this queue station pop. And then I'll do some increment station equals station to list for this queue station. The last entry, if it exists, else it's -1. Okay. Guess that would save a little more overhead. I think that should still work. Right, I mean, up to the 90%. Okay, so cut down extra reference of something that I didn't necessarily need. So grid lists was one I just cut out. So this is actually what I change it to. So this is array of this maps station ID, which is the index, to lists of connected stations for that grid. And then I don't think I need station map anymore. Yeah. So I can remove station map here. Maybe I should call that station map, to be honest. Yeah, maybe I should may have changed this one at a time. Remove instances of the previous stuff first. Grid ID equals station map. I don't think I need that. And I think this still works. Unless I have some reference to the old code somewhere. Grid list not not defined. Yeah, if I need that anymore. Grid lists. Current list, I do need, yeah. Man, this thing takes fucking forever. 192, that even seems worse than before. Okay, I'm gonna call this station map. Well, station map. Okay, so that's fine. List of neighbor stations. Visit map station ID to list of all connected stations for that grid. Actually, do I need the grid ID counter? I think I do actually. Okay, yeah, because I was using that as the index before. So I could possibly remove that as well. Visited station ID, current list, process. Station map to the current list. Current list appends the current station. Should probably do that first. Neighbor of the current station. So we visited, skip it, make it visited true. Add that neighbor to the process stack. Reverse sort the list. It's fine. And then answers empty. Save memory. I don't really know if I like this syntax all that much. Guess it's fine. QType equals 2. Turn off the station. Append if it's on. This thing can be deleted. All station map. Man, if only I could just use a dummy -1 somewhere in that thing. But I can't, I think. Not with reverse sorting. Unless somehow I appended a -1 at the start. Actually, I could... No. No, this needs to be -1, not 0. While that thing's there, and it's not online. Pop. And then after that, main station. Station map. Guess I could just do answer pen this thing. Guess that's a little big of an expression, but whatever. Alright, I think this is as polished as I'm going to make this piece of code. And I suspect this should be the highest I'm going to get to. Okay, whatever. Summary. So this thing had what? This thing had, I don't know. So a few main techniques used. One is create a graph, either a default dictionary or an array of lists to store the connection between all these stations, where the key or the value is equal to key, or the index is equal to the station ID, and the value is equal to the list of neighbors for that station. So that was the main thing. That's pretty much what you always would do for a graph thing. And that was this thing on the graph. And then secondarily is traverse the graph, forming the islands, which are the connected components, is the technical term, connected components, which is the graph, which is in this case is the grid. In this one, use a visited set or kind of array of booleans to make sure that to not redo stations within the for loop. Actually, yeah, so within the for loop, have a while process stack, which processes individual stations, adding them to the current list, which is a list of stations for the grid. After loop, when processing a station, check all its neighbors on the graph and add them to the process stack if they haven't been visited. After the loop, after the process loop, connect or reverse sort the list of stations. Use the last entry, the last kind of valid entry of that list as the node, as the online station for the grid. So this is probably, well, obviously this is the biggest part of it, but saw this code here, going through every station ID, skip it if it's already visited. If it's not visited, say it's visited. Okay, current list of all the stations. This is the current list of all stations of this connected grid. We're going to build that up using the process stack. Process stack initially has the station ID. While there's some station to be processed, take the station, append it to the list, connect it to the mapping of the station ID to the list of those stations connected to it, traverse the neighbors, add the process of any add to the process stack any neighbors that haven't been visited, and then lastly reverse sort the list. And since this is referenced, then all the stations get that same reference to the reverse sorted list. And then lastly use a loop to go over queries, building the answer array for appropriate queries, have an online set or Boolean array, which turn stations offline for query type 2, and use the station / grid list for query 1, and then return the array. Alright, that's it. Time complexity, this can be O of O of n, where n O of n log n, where n is the number of stations, as the creation of the grid lists as a sorting of the stations. Pretty much if everything was connected to one station, or everything was connected to one grid, then this thing in the worst case is going to sort the whole thing. Yeah, and then all the other processes are generally going to be O of n work. All the other for loops and whatever, query loop. I guess this could be it's actually O of Q for processing queries, for Q queries. So overall it should be O of n log n plus Q. Space complexity, or n log n plus O of Q. Space complexity, this should be O of n, what's the worst case actually? O of n squared? Yeah, O of n squared for graph if all nodes are connected to all other nodes in the worst case. Because, no, actually, think of that. So, you have n entries, but the list is all referenced to one list. So actually this might be O of n. This is not redundant lists. O of n. Since there is sharing of the reference to the list of connected nodes. So most size of all the lists combined should be n. Yeah.